Trigonometric functions. The graphs of y equals sine x and y equals cos x. The absolute value of a gives us the amplitude of the graph. B determines the period length. C is the phase shift or horizontal shift. And D is the vertical shift. And I should have said B helps determine the period length. Here we're given two graphs, y equals sine x in blue. And then you have y equals sine of x subtract pi over 2. That x subtract pi over 2 gives us our horizontal shift of pi over 2 units. If you look at the graph in blue, it's going up through the origin on its way up to 1. In the red graph, it's going up through pi over 2 on its way up to 1. That is a result of the phase shift. Here you can see the result of a vertical shift. The blue graph is just y equals sine x, and the red graph is y equals sine x subtract 2, d value being subtract 2, moving it down 2 units. Example 1. We have y equals negative 10 sine 3x plus pi subtract 2. We're going to determine all the values and of a, b, c, and d, and then we're going to find the amplitude, period length, phase shift, and vertical shift. First thing you should notice is that our 3 is not in the right position. The equation was y equals a sine b, parentheses x subtract c plus d. The 3 needs to get outside of the parentheses. We can do that by factoring a 3 out of the terms 3x plus pi. And if you do that, you're going to get y equals negative 10 sine 3, parentheses x plus pi over 3, subtract 2. Now listing your a, b, c, and d is much easier. Your a is negative 10, your b is 3, your c is negative pi over 3 because the equation was in the form of x subtract c, and we have x plus pi over 3, which is the same thing as x subtract negative pi over 3. And our d value is negative 2. Amplitude, then, absolute value of negative 10 is 10. Period length is always 2 pi over b, and b in this case is 3, so our period length is 2 pi over 3. C is just your phase shift, and D is just your vertical shift. Example 2. We want to sketch a graph of y equals 4 cos 2 x plus pi subtract 1. We're going to state the amplitude, period length, phase shift, vertical shift, and at the end we will determine the domain and range. First of all, your amplitude, the absolute value of a is 4, so your amplitude is 4. Your period length comes from the little formula 2 pi over b for both sine and cosine graphs. So if I take my b value, which is 2 pi divided by 2 is equal to pi, so my period length is pi. Your phase shift comes from your c value. Your c value, again, it's x plus pi, but it's really x subtract negative pi to be in the right form. So your phase shift is negative pi, and your vertical shift is the obvious negative 1. All right, well, in order to graph a trig function, you need to know what your horizontal scale is. To determine your horizontal scale, you just take your period length and divide it by 4. In this case, our period length is pi. Pi divided by 4 will give you pi over 4. So every tick mark will be pi over 4 units away on the x-axis. Also, we know that our graph is going to start at negative pi instead of 0 because we have a phase shift of negative pi. And lastly, the amplitude combined with the vertical shift will give your graph a maximum of positive 3 and a minimum of negative 5. Normally, a graph with a amplitude of 4 will go all the way up to 4, but it's got a vertical shift of negative 1, so it goes down to 3. And it would normally go down to negative 4, but again, that vertical shift takes it down to negative 5. So my grid here, you'll see, will go from negative 5 on the y-axis all the way up to 3 on the positive part of it. And the x-axis, we're going to start at negative pi, and every tick mark is pi over 4 units away. I only labeled every second one because there just wasn't enough room to label them without it getting unreadable. We start at the beginning of our graph, which in this case is negative pi. Cosine also starts at its maximum, so it's going to be at negative pi and 3. Our next tick mark for graphing this is just on our horizontal scale. Our horizontal scale says pi over 4 units over, so we're just going to go 1 unit over, and we're going to go down to our midline. Our midline is going to be at negative 1. Okay? Another word name for midline is the sinusoidal axis. So drawing a dashed line at the midline, that's where our next point is going to go at negative 3 pi over 4, negative 1. Then your next point again is going to go to your next tick mark over, which will be negative pi over 2, and we will be at our minimum value, and we're halfway through. Okay, our next point over, one more tick mark over, and we're back at the midline. And our last point for our one period of the cosine graph is going to be back up at the maximum, one tick mark over, and it's going to be at 3. So then you draw a smooth curve through it, and it can continue on in both directions, and there you have the graph of y equals 4 cos 2 multiplied by x plus pi subtract 1. The domain in this case is going to be all real numbers, all sine and cosine graph, unless it's some kind of function where it's got some limits to it, it's going to be all real numbers. The range, if you look, our lowest mark is negative 5, our highest mark is at 3, and so our range is all numbers y such that negative 5 is less than or equal to y, which is less than or equal to 3. Example 3, we're going to write the equation of the function in the form of y equals a sine b x subtract c plus d, where a is greater than 0. So in other words, we're going to start going up from our beginning point. We just got to figure where that is. Okay, well, what can we figure out from this? Well, we know that a is equal to our maximum subtract our minimum divided by 2. Our maximum is 1. The minimum is negative 3, so 1 subtract negative 3 is 4, divided by 2 is 2, and we know our a value. Your b value is your period length, and the formula for period length is not your period length, but it's part of your period length. 2 pi over b is equal to your period length. And so what we're going to do is we're going to find our period length. Notice that red line connecting the two tops. It starts repeating itself after that. And so there we go from negative pi over 6 to pi over 2, which is 4 pi over 6, which reduces to 2 pi over 3, which is your period length. So if your period length is equal to 2 pi over 3, we now have 2 pi over 3 is equal to 2 pi over b, so b equals 3. Our c value, well, we could choose many c values, but as a whole, we want to choose our c value that is the closest to the y-axis on the right. And so in this case, it's in the c values, the sine function starts in the midline, so it's going to be the first point on the midline to the right of the y-axis. It's not going to be a point on the midline on the y-axis because that's going down. Sine starts going up. So our phase shift is pi over 3. And the midline is the d value, which is negative 1. So we can just plug all our values into our equation for a, b, c, and d, and you've got your sine function in this case. Example 4 looks pretty much exactly like example 3, except we got cos instead of sine. Same graph, same a greater than 0. We just got to write it in terms of cosine function. And really it's pretty easy because we already know a, b, and d. We don't know c, but our a, b, and d do not change. Okay, so a is 2, b is 3, d is negative 1. We just need to determine our c value. And again, we're going to start to the right of the y-axis. The first point where the graph is at its maximum value, because cosine starts at its maximum value, is at pi over 2. So d C is going to be pi over 2. And now we just plug it in. Pretty easy, huh? Only because we had example 3 done. Example 5, we're going to use a graph of f of x equals tan x to graph g of x equals negative tan of x subtract pi over 4. Okay, so first of all, we're going to graph f of x equals tan x. Got to remember the tan graph has vertical asymptotes at every odd multiple of pi over 2. So the green line, x equals negative pi over 2, is a vertical asymptote. The graph will not cross that. And then the blue line is x equals pi over 2, another vertical asymptote, and the purplish line is x equals 3 pi over 2. First thing we want to do is shift this graph pi over 4 units to the right, because we have a phase shift of pi over 4. So if we do this, the vertical asymptotes will also shift pi over 4 units to the right. So we now have vertical asymptotes at x is equal to negative pi over 4, x is equal to 3 pi over 4, and x is equal to 7 pi over 4. Notice the points on the original graph, pi over 4, comma 1, moved over pi over 4, pi over 2, comma 1. So it moved over pi over 4 units as well. And negative pi over 4, negative 1, moved over to 0, negative 1. All right, so we've done that part of the graph. Now, the negative out in front is just a reflection in the x-axis. Really what it means is whatever's positive becomes negative, whatever's negative becomes positive. So this point at pi over 2, 1 is now going to be pi over 2, negative 1. The point at 0, negative 1 is now going to be 0, 1. And all the vertical asymptotes are going to stay the same. Okay, reflect about the x-axis, all we're doing. And now you see the graph of g of x equals negative tan of x subtract pi over 4 just by using transformations. Example 6. You've got to find the exact value of tan of 3 pi over 4. You need to have a method to calculate this. I like to use a table I have memorized. It's pretty easy memorization. Or you can memorize a unit circle, which this textbook kind of recommends. So I'll give you a way I do it, and you can decide what you want to do. This is the exact values chart that I use. Here we have the sine, cos, and tan of 0, 30, 45, 60, and 90 degrees. And that's the same thing as 0, pi over 6, pi over 4, pi over 3, and pi over 2 radians. Now, the top row is really all you have to remember how to get that. Well, really, it's 0, but that's square root of 0 over 2. 30 is square root of 1 over 2. Then we have the square root of 2 over 2. Then the square root of 3 over 2. And lastly, we have the square root of 4 over 2. If we simplify, we get what we have now, 0, 1/2, root 2 over 2, root 3 over 2, and 1. To get the second row, all you have to do is reverse the order. What's last becomes first, and vice versa. So we get 1, root 3 over 2, root 2 over 2, 1/2, and 0. And to get tan, all we do is we go sine divided by cos. 0 divided by 1 is 0. 1/2 divided by root 3 over 2. All we do is we multiply by the reciprocal, so we get 1/2 times 2 over root 3. You get 1 over root 3. If you rationalize, you get root 3 over 3. For 45, anything divided by itself is 1, so that's where you get the 1 for tan there. For 60, root 3 over 2 multiplied by 2 over 1 will give you root 3. And for 90, you cannot divide by 0, so it is undefined. So how do I use this? Well, we know that 3 pi over 4 is a second quadrant angle with a 45-degree reference angle. So what you want to do is you want to find the tan of 45. The tan of 45 is equal to 1. And we're in the second quadrant. Tan is negative in the second quadrant. So my answer here is just going to be negative 1. Let's look at 7. Here we want to find the exact value of secant of 4 pi over 3. All right, just to quickly show you a quick way of getting this angle if you're not comfortable, it's been a while. Well, 4 pi over 3 is a third quadrant angle. Where do we get that from? Well, if you start in the first quadrant, you would get pi over 3. Second quadrant, you get 2 pi over 3. The x-axis would be 3 pi over 3. And then in the third quadrant, we get 4 pi over 3. And we see it is 60 degrees from the x-axis. So it is a 60-degree reference angle. Bringing the chart back in value, here we get secant. Secant is a reciprocal of cosine. And we find the secant of 60 degrees, or the cosine of 60 degrees is 1/2. So the secant will be the reciprocal of that. And also it is in negative in the third quadrant. So secant of 60 is equal to 2, but secant of 4 pi over 3 is equal to negative 2 because it is in the third quadrant. All right. Last example. Find the exact value of sine of negative 5 pi over 4. Negative 5 pi over 4 is a second quadrant angle with a 45-degree reference angle. And again, you could just draw that like that. If there's your angle drawn in standard position. We're going clockwise to get negative 5 pi over 4 to that angle. Notice we've got that 45-degree reference angle. That's what your angle would look like. You need to draw it. Well, if it helps you, by all means do it. So now we can bring our chart into play here. We have a 45-degree angle, and it's in the second quadrant. And so we have sine, it's going to be root 2 over 2. Sine of 45 degrees is equal to root 2 over 2. Sine is positive in the second quadrant, so our answer is just going to be sine of negative 5 pi over 4 is equal to root 2 over 2. Done.